So if you balance the equation correctly, you should end up with this. All right, so you have 3 sodium carbonates plus 2 iron 3 nitrates gives 6 sodium nitrates plus iron 3 carbonate. All right, so if you go through your precipitation rules or your solubility rules, you should be able to figure out which compound precipitates. In this case, so most carbonates precipitate. Iron is not one of the exceptions, so this is our precipitated compound. Right? All nitrates are soluble, just across the board. Doesn't matter what nitrate it is, they're all soluble, so this one's soluble. We don't have to worry about that one. All right, so now we have our balanced equation. All right, in the problem, we're given the volume and the concentration for both of our reactants. All right. When we're doing theoretical yield problems, this thing we're always trying to get to is the number of moles of each of the reactants that we have. Because the next step we want to try to do is just like calculating theoretical yields that we've done before. So we start off by balancing the equation, which we've already done now. Second step is trying to figure out what's the limiting reagent. So in order to figure out what's the limiting reagent, we need to know how many moles of each of the compounds we have. All right, so we now know how to calculate the number of moles given the concentration and a volume. All right, so that's this equation that you guys have seen now several times. So the number of moles is going to be equal to molarity times the volume. All right, so we're going to go ahead and do that now for sodium carbonate and iron 3 nitrate. And so I've already converted, things like milliliters, what were the units you're given? Yeah, milliliters to liters, and I changed millimolar to molar for us. And you end up with these moles of the two compounds. All right, now, if you remember, now that we know how many moles of each of the two compounds we have, we can figure out which one's the limiting reagent. All right, so for that, we now need to look at the coefficients, from our balanced chemical equation. All right, so we're going to take one of these two. We'll go with the number of moles of sodium carbonate here. We're going to convert it to how many moles of iron 3 nitrate we would need to completely react with that compound. All right, so the way we're going to do that, we take these moles of sodium carbonate, and we're going to, so for every 3 moles of sodium carbonate we need 2 moles of iron 3 nitrate. All right, so you do this math here, and we end up with this many moles of iron 3 nitrate that we need in the reaction. Now we compare that to how many moles we actually have, and it turns out we have more iron 3 nitrate than we need. So this means then that which chemical should be limiting. I'll leave that to you to figure out.